Okay. Nice. I see some crabs and bears. All right. Okay. Cool. Hey. So yeah, I'm Sam, the co-founder and CTO at Oso. I was previously in London and did attend a Rust London meetup before I ran away to New York about 3.5 years ago. But it's for a good cause, I swear. I came out to New York basically to start Oso, this company, and really the whole mission behind the company is about making security more accessible for developers. And one area we're looking at for that specifically in the right now is around authorization, and I'll talk about that in a little bit. So for me, me personally, I've been using Rust for about 6 odd years now. I think just after it went 1.0. I learned about it while I was doing a PhD in cryptography, and it's like very, very good fit for solving that kind of problem. The safety guarantees, plus the efficiency, plus the ability to do kind of low-level cryptographic protocols. It was a great fit. So I kind of fell in love with it. And so when I was starting my own company, I was in the position to be able to say, hey, we should use Rust. So we are. Okay, cool. So I basically have 2 goals. I kind of want to show off what we've been working on at Oso because I just think it's really cool, and I want to share it with you all. But it's also really the kind of the motivation and the why behind some fun stuff that we had to do in Rust, and it just kind of takes you into some corners of Rust that you maybe haven't had to go into, and I think they're kind of cool. So going to set up the problem of like how we ended up in this, what we had to try and solve, and then talk through the parts of Rust that solve that. So yeah, basically here's the outline. Okay, so starting with Oso. So what we're building at Oso is an open source authorization system for developers. So this is the thing that allows you to basically answer the question of who can do what in my application, right? So you're building a web app. Most of them that we think about are B2B, business to business. Take something like, I don't know, GitHub, for example, and you decide, can this user see this repository? Can they close this issue? Things like that. And so the core of Oso, though, is a library. This is the library piece that helps you, build this into your application, so into your web app. And we basically made this library available across a bunch of different languages. And the kind of, so all of these are just available through, regular package managers, things like that. But basically what's powering all of them is Rust. So what we effectively did, we built a policy language for authorization, which we call Polar. That bit is built in Rust. And then basically we've sort of embedded that in a bunch of different languages, either via like a C-style API or actually in the case of JavaScript through like a WASM API. Or in the case of Rust, it's just Rust to Rust. And so I was just thinking about this, after the previous talk, the flexibility of Rust kind of goes in all directions, right? There's like definitely a platform compatibility thing, piece here. And I think one of the things that I'm really excited about for Rust specifically is this ability to build the core of like an SDK or a library or something like that, and just having the all of the advantages that we heard about in the last speak, being able to make those available to like these higher levels. That bit's been a lot of fun. And actually, if you can start seeing like more and more companies taking this approach of like building the Rust core and then just like exposing it through like a wrapper on top. So that's kind of cool. Okay, but let me tell you just a smaller bit about how Oso solves this problem of authorization. I'm only going to touch on it very briefly and really just use it as a segue into talking about some fun Rust things. Okay, so the first thing you get from Oso is basically this very simple interface or API for asking authorization questions. And basically what this looks like is oso.is allowed, and it takes in, this method takes in an actor, an action, and a resource. Wow, it's really being aggressive with suggestions there. Let's make this Rust. And technically this returns a result. So this is what it looks like in Rust, for example. Now I need to change comment type. So this is what it looks like in Rust. And so basically the authorization questions can be expressed as, is this actor, which could be a user or a group or something, is this actor allowed to perform this action on this resource? And I'll kind of look at a concrete example in a second. And basically, this is like the core API for pretty much any authorization thing. And we have a bunch of other support for, for example, in JavaScript, this API is instead using JavaScript style, camel case, but it's still just actor action resource. In Python, so is allowed actor action resource. So this is kind of like piece one. And actually, like the thing that we found was really cool about this is it just gives you a structured way to think about authorization, about deciding what can be done inside your app in this pattern. So for example, say I have this is some Python code here. Say I have my Python web app. It takes some data in, it creates a new project and saves it to the database and returns a response. If I want to do authorization here, like should this user be allowed to create this project, I just use that little API. Oso is allowed. In this case, it's the user. They want to create this project, right? And this will return like a Boolean value. So like if they're not allowed, let's like return, I don't know, none and a nice 403 for them. All right, so that's like piece one of Oso. The library, you install the library and you have this is allowed method to ask your authorization question. Now, this by itself is just an API, so there's not really a whole lot going on there. The power of this API though is kind of the piece that backs it, because I think like typically to solve this kind of authorization problem, what you see is like a bunch of these like if-else statements you miss, like maybe if the user, maybe it's got like an is-admin field. I don't know, like otherwise if the user is equal to the, I don't know, data user ID or something, then we're gonna do something else, like else, I don't know, maybe the user has to, you end up with these like cascading if-else statements. And so the idea is that with Oso, you just put it behind this like one method, and then you write policies, authorization policies that say who can do what. So this is where I mentioned briefly, we built this core piece in Rust. This is the language Polar. This is how you express these authorization rules. And there's some cool things about Polar. So it's a declarative language. So you just basically tell it, here's how I want authorization to work, and we figure out like how to piece those bits together. You do it by expressing rules. And the final piece, which is very relevant for this talk, is how we make use of application data. So in Polar, the rules you write, they mirror that is allowed method. So you write like an allow rule, and it takes in the actor, the action, and the resource. But this is where you're saying like if this is allowed to happen on. This is like implementing the is allowed almost. So you can say, the actor is allowed to do something if some conditions hold. So in the previous one, we passed in a user object. We specify the action should be create, and the resource was a project. And so this is kind of, you can sort of see the Rust-ish syntax here. The user is expected to be of type user, things like that. So I could say, the user is allowed to create this project if the user is an admin. Maybe that's my first rule. And well, we had some other ones, right? User ID is equal to the project or owner ID or something. And the piece about this being declarative and rule-based is you kind of just like write, ways that the user might be allowed, and you don't need to say like first try this one, then try this one. Like Oso handles that. So that's like the declarative and the rule piece. The application data piece is this is kind of a few bits in here. So first of all, this like type check kind of thing. It's basically like it's a match almost. It's like a pattern match. So this rule, I should use this rule if the input type is of type user, and this user object is coming from the app. So it's coming from, it's a Python class, it's a Rust struct, something like that. And similarly, like reading this is admin field, I'm expecting that I've got, a user class, a user class, and it has a admin field, which is like a Boolean, right? So these are kind of being pulled straight off the Python objects, and you can see it's just like passed straight in, right? So this could be a user type, passed into is allowed, and then you can just read is admin straight off it. And so basically with this, you can now start writing authorization logic using this policy, and this is kind of like just the beginning. Like from here, we also give you like templates for common like authorization models and a bunch of other cool stuff. But we've sort of reached the point here that I wanted to get to, which was talking about this like application data piece. So for us in building this, it was like incredibly important that you could just do this user.isAdmin. Like I shouldn't need to, I don't know, like figure out what data I want to send in here. Like first, like I'm going to pass in, this is a dictionary, and the isAdmin field is set by checking that user is admin or things like that. Like I don't want people to have to think about like what data I pass in. They should just be able to pull it straight from the app. So how do we manage that? And that's basically, obviously, Oso policy is written in its own language, or you write your rules in the language that you're using Oso with. All right, so great, great question. So everything I'm showing here is in the Polar language. So this is the language we built for authorization. So this like allow if, this is a declarative rule. So this is all written in Polar. You write your rules in Polar, but it can access data from the application. Okay. I'm also happy to take questions as they come up, so it's all good. All right, so like the thing that's happening here in reading that like isAdmin fields is basically a concept called reflection, where I'm like reading data dynamically at runtime off of an object. Now in Python, this is like super easy. For example, let's do my class user. Let's create a little user class in Python. And I'm just gonna like do this really hackily and say whatever. I have a user and the isAdmin field is true. I can use like Python's built-in getAttr thing to like dynamically get a field, like get the isAdmin field off of the user. It'll give me like the true, but if I try and get the like is staff or something, I'm gonna get like an attribute error. Python, super dynamic, so this is like no problem. Rust, compiled language, statically typed, a lot more stuff like that is enforced. So we had like a way harder problem in front of us to address this when we wanted to support this library in Rust. So in the process of doing so, it was a pretty fun problem. So we ended up writing like a blog series on all the stuff we had to do. And basically the talk I'm giving here is like an abridged version of this that you can find on our blog. So there's kind of like three kind of cool pieces that came up. First is like how you have some concept of a class. Second is how you read attributes, and the third is how you call methods. I'm going to go through these each. So the class piece, I just kind of spoke to you about a little bit, right? I said, the user could be a user. So in this rule here, I want to make sure the input type is of type foo. So how can I dynamically at runtime check what type something is in Rust if I just have like an object? This kind of already exists in Rust, funnily enough. So this is like any trait, and you can kind of see here, right? It's a trait to emulate dynamic typing. Basically, what the any trait allows you to do is sort of forget or sort of erase like the concrete type of something and just treat it as like it could be anything, right? Hence any. But it carries around one small piece of information, which is like the identifier of the original type. And so you can kind of use this to like recover something's type dynamically at runtime. So there's like a little example in the documentation here where you see they have like a method isString that takes in any type and then will tell you if the thing is a string or not. And so 0 is not a string and the Cookie Monster string is indeed a string. And so this was like piece one of what we needed, right? Because we would be, when we're evaluating our rules, so like these rules here, we get in an object from Rust and we need to determine like, oh, is this a project? Should I use this project allow rule, or is this something else and it doesn't apply? So we need to be able to do those like dynamic checks based on effectively like a string identifier. Like I'm looking for a project. Do I have a project? And so this was kind of like that piece we needed to do that like little bit of type checking at runtime. And so when we started kind of going down this path, we started like kind of realizing what we're sort of doing is kind of recreating like a dynamic class system in Rust. And so that's kind of how we like encapsulated the logic in the code itself. So for example, I have this class.rs file inside the Rust project. And you can see, for example, that we like, for a class, we carry around the name of the class and like the type ID of it. And that's the thing that's coming from that any trait is this type ID. And so like this is what that like project identifier refers to. It's like the project is the name and the type ID is like what Rust's internal identifier for that project struct would be. And then basically so that's like one side of it is like the class definition, and the instance side of it is using this any trait to go away. Is using that any trait to basically allow us to pass around an object where we don't care what type it has. So an instance is like an instance of any type. It could be a string, it could be a number, it could be a user, it could be whatever. Just like hide that type from me, and then basically we're using that like that type ID checking things here to just to see if something is an instance of something. And so let me show you a little example of what this looks like through our tests. So I have a foo struct and a bar struct. I create like a class definition for each of those. And then I create an instance, one of those instances, and I pass it in a foo. So this foo instance here, like at this point, it's kind of been like, it's been converted to like a fully dynamic object. It's like no longer a foo. Like I can't call foo methods on this instance anymore. It's just an instance. But I can still check what type it is. So I can check is a foo instance into a foo class, and it's not an instance of a bar class. So we have kind of made these types pretty useless in that all we can do is check what type someone gave us. This is piece one at least. We have piece one. So that's like our dynamic class stuff, right? So we can now write rules. We can now write the first part of this rule. I can check the input type is a foo, and that is it. Next thing is, okay, so what if I now want to like actually do something useful? It's like, okay, I know this, now I have a foo now. What if foo is a Y field I want to check, right? What if the project has an owner ID that I want to pull off it? Like, how can I get that? Now, this is like, from here is like, I, felt like, we sort of like stepped into a puddle that we thought was only like an inch deep, and then turned out it was like down to your waist. I should have like an image of that to make that point. Because this was so much harder than the anything. And basically, there's like this sort of, I don't know, thing I hadn't really thought about until we tried to do this, which is the layout of a Rust struct is is at runtime like not stable. Like you cannot depend on what am I trying to say? Like the internals of a struct, like the attributes, are basically fully opaque at runtime. Because like Rust reserves the right to like rearrange fields inside a struct. Let me write an example. Actually, I think this will be clearer. I know. So I have I'm bad at naming, so I'm just gonna go with foos and bars still. And I have my foo struct. It's got a few fields in it. Something like this. Basically, Rust is like at runtime, at compile time rather. Like Rust is kind of reserves the right to rearrange X, Y, and Z, like X, Y, and Z, however it feels necessary. So for example, API, thank you. Yeah, that's the right term for it. So for example, if it's like, the layout of this is very inefficient because I could fit that ball and that U8 like side by side, and it's going to take up less space in memory. Rust will do that for you. In C, that's not the case. Like these will have like known offsets. You can compute where they are. So if you have a pointer to a foo, you can do the arithmetic and find exactly where X, Y, and Z are. You can like opt into that behavior. You can basically say like repr C, like leave my struct alone and don't rearrange it. But for us, that was sort of a little bit of a unfriendly thing to do, I'd say, as like a library creator, is to require people do things like this in order to use our library. So that was a no-go. So we kind of like started looking into all these like crazy approaches. Like I'm a huge fan of Serde and like have written various serializers, deserializers with it, things like that, and different formats using it. So my kind of mind jumped there, but it didn't quite feel like the right fit. That's serialization is really about like data formats. It's not about this like accessing accessing fields, things like that. Oh, good point. Like you're right. If even with this repr C approach, it would have been very unsafe to do the pointer arithmetic to find the fields. The repr C thing I think is fine, but like I'm not sure Russ would be too happy for me to say like I'm gonna work out what the fields are. Don't you worry about compile time checks. So we tried a few approaches. None of these have quite worked. And we basically fell on this approach of like an attribute getter. And so the idea is you basically, you tell us by, well, I'll talk about how this actually, how it actually gets built eventually. But you basically provide a method that can pull the value of the attribute off of a struct. Now, basically, what this means, right, is obviously you can reference attributes in your code, right? It's not like it's impossible to pull an attribute or a field off of a struct. You obviously can do that. And like once you've done that, like Rust kind of like knows how to access that value. And so basically what we do is we kind of require that you kind of give us a method that, or like a closure or something that tells us how to pull an attribute off of a struct. So for example, this would do it. Like it's something that takes in foo, returns a u8 and and does foo.x, right? This is now a method that will get me that value of x. And this I can like happily consume, make dynamic, wrap in this like arg trait function thing, and basically kind of effectively like hide all the types and make it become like a kind of a runtime based thing again. And so that's kind of what we have. And the way this looks, what's a good example of this? Again, going through the tests. Yeah, so what you're seeing here is that we've provided proc macro to do this kind of work for you. I should have ones with, here we go. So, okay, oh, quick, cool, yeah, that's my foo one as well. So suppose I have a foo class, foo struct rather, with an x field, returns 964. Then basically when you're creating that class definition again, so the place that we're storing everything we know about foo, we put onto this like foo class. So it's named foo. We pass it an attribute getter. So this is a closure that just expects a reference to the instance and returns the field you want. There's some kind of like nice aspects here. So like if I change this to like string, well, first of all, this .x isn't a thing on a string. That's one compile problem. But like the signature of this function is actually expecting to get an instance of foo. So we've like we like added a constraint in the. Actually, I'm going to show the definition of this. So I'm just show the error, right? So it was expecting a signature with a foo, and it found one with a string. And basically, we use the Rust type system here to add and like the generic bounds to add an additional constraint onto the like what you can give us that we didn't technically need to. Like we didn't need to specify that this must be of type T, where T is like on the class builder, but we could. So we kind of like enforce that, and it means that you're getting this nice like compile time assertion that you are giving us an attribute from the right struct. So that's how we went about doing attribute getters, and it basically means that we can now start doing. I should say as well, this is like very inspired by how it works in like Python, right? So when I did this like get attr, this is kind of like the same thing we have to do at runtime. Is we basically the user object kind of like has this like magic dictionary underneath it. Or you can kind of do dir as well, as if you think, there's this like crazy, all these like magic methods set on an instance in Python, which is basically just a hash map from attributes to how you get them. It might be a method or it might just be a straight attribute. That's basically what we just have. We just create a map between the string name of a thing you can get and the way you get it. Cool. So that's like piece 2. We can now like get attributes as well. The final thing we wanted to support was method calls. And again, this is where things kind of like got turned up to 11, because attributes are somewhat simpler because you don't have to worry about things like the input arguments, and in particular how many there are. So the first idea was just like, all right, well, whereas an attribute getter just took an instance and returned a value, now we need to take in a bunch of arguments as well. And there could be multiple arguments. We're like fully dynamically doing this at runtime, so we don't know how many. But this became like really problematic because, when I went about trying to implement like a trait for this, so I could kind of say, you give us a function and we'll like wrap it in the right thing. I ended up getting like these really, really bizarre compilation errors, and it related to things like, it would complain that if you look in this trait, it would complain that like A is not specified anywhere in the function definition, in the trait implementation. I'm like, well, like it's right there. You can see it. Like, how is it not defined somewhere? It's there, and you can like add A up here, and it still wouldn't be happy, and things like that. And basically, it was kind of like this problem where it's like very hard to parameterize over all functions with like possible inputs and types and things like that. I won't go too much into this one because it gets like very into the weeds, but we like wrote it up at length in the blog post. And so, basically we tried like a number of different things. I think eventually we realized that what we basically needed was like the arguments had to be up in the like generic bounds on the trait. And it's for like a very, very subtle reason around like how Rust resolves traits and like how things could be ambiguous. Yeah, so I think other than that, there was like, some other like kind of interesting pieces on top of this, like things like how we then dealt with class methods. So, the piece that we just had before was like calling a method on an instance. So I have an instance of foo, I can call a method on it. But what if I want to call like a method that doesn't have like a self, basically? It's just like defined on the structs. Like, how can you do that? And again, we like took some inspiration from Python on how to make that work. Funnily enough, like once I started kind of trying to write out my thoughts and sort of do some research around like what was going on and like understand what was happening, I actually found like a bunch of other examples of projects that were kind of facing these similar issues. It seems like, embedding, using Rust to like embed as a language is kind of a popular thing to do. And even to a certain extent, this idea of like embedding Rust inside Python or being able to use, interact between Rust and Python like has these like similar problems. And so like you look through these other projects and you see those like same patterns of how can I like parameterize Rust methods in a way and then like have these traits that that are automatically implemented for all methods. Oh, actually, I do want to show one thing, so it's kind of fun. Where was it again? Method. Right. Yeah. So here was our trait. So basically, a method is something that can be invoked and it takes in some arguments. The arguments would be like, there isn't a way to just say like variadic numbers of arguments in Rust, like a tuple of any length, basically. So what we had to do was basically write this pretty gnarly macro that would expand, for I think up to 16 different methods, function inputs, parameters, and things. Expand the macro out and write like an implementation for like a function with 1 input, with 2 inputs, with 3 inputs, with 4 inputs, with 5 inputs. So each of these will be like, I implement the method where it can have like 5 different inputs of different types. And then like the macro here basically generates all the nice wrapper code that just makes it work. And the end result, as we kind of saw here, was like, whereas add oh yeah, this is a great example. So we have a foo method. It just returns a vector with 3 elements in it. The way you register it, you just say, oh yeah, the Aslist method, and you can just or actually it can be iterated around as a list. You can just pass it in like as the Rust function. And it was like really hard to get all the types and the trait implementations right, so that you could just do this and not have to write like a bunch of extra syntax. So yeah, and these other languages all have like similar things they address. Cool. So that's everything I want to cover. I'm just going to straight up copy paste these into the chat box so you can all just click on them instead of trying to furiously type. But basically, yeah, if you want to learn more about Oso and what we're up to, this top link's good. You could go dig into the source code, see some of the crazy Rust shenanigans we're doing, or oh yeah, I guess I should have said. I think I said at the beginning, right? Oso is all open source right now, so we have a growing community around the open source thing that we're always happy to have new members just to come talk about authorization, Rust, Oso, whatever. And you can find me on Twitter at SamOsososos. Yeah. Oh, and thank you, Steffi. Yes, as Steffi said, I've also been doing like Twitch streams, going through various parts of like the Oso development. I've got a really fun one coming up next week, actually, on building the Google Zanzibar system in under 60 minutes. So there's this like pretty cool paper from 2019 about Google's internal authorization system. It's this like super crazy powerful thing. I'm going to show you how you can build it in 60 minutes. So that's coming up on the Twitch link that Steffi just shared. Okay, and yeah, happily, I think I have time for questions. Maybe we're doing the Q&A. Oh, I see the Q&A now. Nice. Yeah, let me answer some questions. Oh yeah, so there's the earlier question from Arif. So yeah, again, just a reminder, the policy I've been showing, that's all like in a language that we've built specifically to have these like properties that it can like access application data, and that's where this like reflection piece comes in, right? So you can build your like Rust web app, and if you want to do some authorization, and the authorization checks need to like do a bunch of these conditions, you get to, oh, which tab is it in? Let's close some tabs. You get to write your authorization logic in this like very concise, expressive, declarative language, with the convenience of just like pulling those attributes straight off your like Rust structs and things like that. It makes it very nice to work with. Cool. And that's another question. Do you find you need to split it up into two auth calls, one for client-side validation and then another more rigorous one for server-side? That's a great question from Giles. So there's like a few pieces to this, right? So like if you think about like using a typical web application, there's the canonical source for authorization, like the place where you can actually do enforcement has to be at the server. Because if you just had your authorization logic like in the browser, someone can just like go and see what it's doing and bypass it and go and make the request like manually. So like you absolutely like have to do authorization on the back end, and that's like often where like the central source of truth will be for who can do what on your app. But what you would love to have is you don't have this like experience where users like clicking stuff and it's like not allowed, you can't do this, and like popping up with error messages. So like you really want your like front end, your client side, your UI, whatever it is, to be like aware of authorization. And so kind of the question is like, how do you do that without potentially duplicating everything across both sides, without maybe being very like performant inefficient, things like that. So we actually have a guide on that on the Osodox, and basically what it kind of the approach we take is you can actually use Oso to basically ask questions like, what are all the things this user can do to this resource? Basically get me what permissions I have on like this piece of data. You can basically use that to like extend the data models like that you return to a front end, and then you can like in the front end very, very easily say like, I won't show the delete button if the user doesn't have delete permissions, without having to like re-implement all the authorization logic. You just have like, oh, I can check like these sets of conditions really quickly. I guess rules and a policy are ANDed together. Are there other ways of combining rules or even policies together? So rules here actually, you could think of these as being an OR. So each one of these rules is like self-standing. Like this first one says, allow a user to create a project if the user is an admin. I'm like declaring that is true. So like that is what I want to happen. I've answered the question. Alternatively, allow a user to create a project if the user is the project's owner ID or something like that. So I don't know. Hey, you can imagine admins can create projects for other users or something like that. So this kind of like sort of works like an OR. Like I could write this as users admin or this. I could like combine the conditions into one rule. But I don't like this because it's combining two very different pieces of logic. There is like two very separate rules happening here. Rules meaning in both like the natural language sense and also like the code we wrote. I way rather would have this separate and like have a nice little comment. Admins can create projects. Maybe admins can do anything. So I just can change this to can do anything to projects. So that's like the general way that you go about like combining rules as they work as ORs. If you, I don't know, you can start like breaking these out into other rules though. They don't have to be just made up of allow. That's just like the entry point. So I could write one which says like, user is an admin if user.is admin, pull that piece of logic out. I could say, so I want to check the user is admin, and I want to check that like, I don't know, doesn't exist or something, the project. So I can start like combining rules together like this to build up like more complex logic. When you start out, these typically are all in like one policy file, and then like over time you'll like break them out, split out some of the logic, and then like I think one of the coolest things we have going on at the moment is we are basically making this. You don't really need to think about like how do I build and structure these policies. That you can just use what we have out of the box for like roles. So there's an example here. Let me make this bigger. For example, this is some of the new stuff we have. This gives you like a fully implemented role-based access control model that can do things like cascading permissions between resources. So like, here you can read an issue if the issue belongs to a repository. It's defining the roles. It's doing all that. So actually, we're kind of moving towards making it so you don't necessarily need to think about like what's the right way to like structure my code. You can think about it as being like, we built Rust and now we're like building the standard library, so you don't need to implement a linked list or something like that.
Great. Sam, thank you so much.
Cool. Thank you everyone for listening.